Welcome back to my new video. In this video, I am going to give you some line maps on organic chemistry reactions. If you go through the line maps, you will almost revise all the reactions of organic chemistry in class 12. So let's get started. Video is also helpful for NEET students and other students. So let's get started. So here, if you see, I am going to start. I am going to start with from very scratch. I mean, the first reaction I am going to teach you. First reaction will be from very basic level, and I will go till very little bit high level. So you'll revise all the reagents, all the products, and how the reagents work, everything. So the first reaction, first line map one. So let's start. Line map one. Line map one. First, CaC2, calcium carbide. If you give water in CaC2, if you give water in calcium carbide, it converts into CH triple bond CH, that is ethine. So this is a very simple reaction, remember this. Now when you give red hot copper in this, when you give red hot copper in ethine, it gets converted into benzene. So these are very basic reactions. I am not going to explain these basic reactions. When the very nice good reactions will come, I will definitely explain all of them. So first two reactions, CaC2, calcium carbide, water, ethine, red hot Cu, benzene. Simple. Now if you give O3 ZnH2, this is reductive ozonolysis. This is reductive ozonolysis. In class 11, you have studied this. I will explain what happened, but first let me write the product. Basically, what happens from if you give O3 ZnH2O in benzene, CHO, this is formed, and 3 mole of this is formed. But how it is forming? From 1 mole of benzene, 3 mole of this is forming, but how it is forming? Let me explain that. What happened in this reaction? Benzene. You all know benzene. What happened in benzene? 3 bonds are there in alternate positions. Right. Now, when O3 ZnH2O is given, what happened? This bond gets broke. Okay. And in every site, one OH is attached. Means how? If we break this bond, suppose we are breaking this bond, then what will form? Like this. Right, like this will form. Now here one O, here one O, here one O, here one O. Same way here one O, here one O. So if you take, each of them is a unit, and all 3 of them are same. So if you take this out, one of them, it is nothing but this one. That is CHO, here CHO. And if you see 3 products are forming, so that means from one benzene 3 moles of this glyoxal is forming. Right. This is what the reaction I have explained, reductive ozonolysis. Now if anything comes, means for example, like this product is coming, if you are given O3 ZnH2O, then you know that we have to break this bond. We have to break this bond like this, and we have to attach O, so it will form this product. You know this reaction. By benzene I am explaining this, so if any other things come and their double bond is there and ozonolysis is happening, reactive ozonolysis, then this will happen. For reactive ozonolysis you have to memorize the reagent, that is O3 Zn-H2. This Zn means reductive. Now if you give in this glyoxal, if you give NaOH 50%, NaOH 50%, right, it will form CH2OH 3 double bond O minus Na plus. Now why this is converting to acid Na minus Na plus, but this is not converting? Because 50% you have given. If you have given 100%, then both of them would have converted to C double bond O minus Na plus, both of them. But as you are giving 50%, so only one carbon is converting to acid salt, means C double bond O Na minus Na plus. But if you give, now if you give, this was a reaction, one reaction, this was another reaction taught. Now if you give here red phosphorus and HI, in this product, if you give red phosphorus and HI, if you give red phosphorus and HI, this will get converted to a very simple product, that is CH3CH3. There is no other alternative of remembering or memorizing this. You have to memorize this, that from here if we give red phosphorus and HI, this is forming. Simple. Now monohalogenation reaction, that is Cl2H nu. I hope most of you know this reaction. If you give Cl2H nu, what happens? It gives many types of products, means how many types of hydrogen will be there, that many types of products will form. Means for example, in this case only one type of hydrogen is present, so it will form, give only one product, that is CH2 CH3 CH2 Cl. Means Cl will attach to one side of carbon. Now if you attach this Cl on this side, then also same product will form. If you attach this Cl in this side, then it will be Cl CH2 CH3, or if you rotate that, same product is only coming. So there is all types, there are only there is only one type of hydrogen, so only one type of product is forming. Now I will let you know the other types of this reaction. So let me explain the types. For example, if there is CH3 CH2 CH3, this product is there. Now if you are giving Cl to H nu, how many types of product will form? First product CH3 CH2 CH3 CH2 Cl. Because if you see, this hydrogen is attached to first order carbon, this hydrogen is also attached to first order carbon. So that means this hydrogen and this hydrogen are same. So if you attach chlorine in here or if you attach chlorine in here, it is same thing. But if you attach chlorine in the middle carbon, because the middle carbon is second degree carbon, second degree carbon. So that means if you attach chlorine here, that means that will be a different product. But you can attach, because how many types of hydrogen are there, that many types of product will form. Here two types of hydrogen you can see. One H3 both are first degree carbon attached, and this H2 is attached to second degree carbon. So another product will form, that is CH3 CH CH3 Cl. I hope you understand. Like that, how many carbons, how many different types of carbon and different type of hydrogen are there, you have to replace each one of them. Means for example, another product I am making, if you see CH3 C CH3 H CH3 CH2 CH3, this product, if you give here Cl to H nu, how many products can form? If you see carefully, this carbon and this carbon are same. If you see, both are first degree and both are attached to same carbon, both are CH3 CH3, means you can treat both of them as a one unit. So first I will replace one hydrogen from this Cl CH2 CH, CH2, CH3, and here CH3. Or I may have given this Cl in this carbon also, the product would be same. Now another product, this both we have done, now this carbon, this third degree carbon, this is different, so we can attach here also. Here hydrogen is present, that means if hydrogen is present, that means chlorine can be attached, so it will be CH3, C, CH3, CH2, CH3, Cl. Same way, this carbon are also different, because if you see, this is ethyne group, and it's at this carbon is away from this third degree carbon, so it is also different type, and here also it is different type. Same way another product will come, that is CH3, CH3, CH, CH, CH3, and here Cl. Another product CH3, CH3, CH, CH2, CH2, Cl. Now you can see, for this only one reagent Cl2H new, how many types of products are forming? 4 types. Depending on the number of hydrogen, the number of different type of hydrogen, there are many different type of products can be formed. So I hope you have understood this. I hope you have understood this. I hope you have understood this. Now let's go. Sorry for the interruption. Let's go to the next. Now if in this product CH2, CH3, CH2Cl, if you give alcoholic KOH, what will form? Alcoholic KOH always does elimination. Remember, alcoholic KOH, remember this word, alcoholic KOH always does elimination. Elimination means the Cl will be removed, and if Cl is removing, it will take one hydrogen, so it will happen, it will do CH3, CH2, double bond CH2. Now how this reaction is occurring, let's understand. What was there? CH3, CH2, Cl. Now when alcoholic KOH is given, this Cl and one H from here is removed as HCl, and this bond is formed, that is CH2, double bond CH2 plus HCl. This is elimination reaction. Alcoholic KOH is given. Now if you have given here aqueous KOH, then the product will be different. If you have given aqueous KOH, aqueous means hydroxyl group, that means OH, then it will form CH3, CH2, OH. Just replace the Cl by OH. This substitution reaction. This is substitution reaction. And this is elimination reaction. When alcoholic KOH is given, elimination occurs. When aqueous KOH is given, substitution occurs. When alcoholic KOH is given, elimination occurs. When alcoholic KOH is given, substitution occurs. Right? Now, so what is formed? CH2 double bond CH2. Let's check the next page. What was there? CH2 double bond CH2. And in this, if we give again O3 ZnH2O, we all know this is a reductive ozonolysis. What happens in this? In this, only a simple thing happens, that CH2, this double bond is broken, and this CH2 and this double bond is substituted by with O. So this is happened, and it's a simple product. How many of this product is formed? Two products are formed. So it is nothing but 2 times CH2 double bond O. And if you write this is nothing but HCHO. 2 times HCHO. Simple. 2 times HCHO. Right. So now CH2 double bond O. When in this you give Zn HgHCl. Zn HgHCl. It does reduction. Reduction means oxygen is removed and in the place of oxygen hydrogen is attached. So simply CH2 double bond O. If oxygen is removed, so in place of oxygen hydrogen will be attached, and we know oxygen has 2 hands but hydrogen has only 1 hand. So here we need 2 hydrogens, so it will be nothing but CH2 for one oxygen, 2 hydrogen will be attached. 2 hydrogen will be attached. It is CH4. Now in CH4, if you give Cl2H nu, we all know there is only one carbon and only one type of hydrogen is there. So only one product will be formed, that is CH3Cl. Now in this CH3Cl, if you give KCN, if you give KCN, then it will form CH3CN. CH3CN means this K and Cl will attach, and byproduct as a byproduct is KCl, and the Cl will attach to the carbon chain. Now there is also one type of this reaction. For example, in this case CH3Cl was there, when KCN was given it was CH3CN. But if same thing is given but AgCN is given, that time CH3 NC will do. NC will come. NC. But why NC? Because if AgCN is there, then this CN, this electrophile attacks from this the lone by the lone pair of this N. But when KCN is there, K is easy to remove. That time this CN will attach by the negative charge in the head of carbon. So you just remember that when KCN is there, CN is attached. When AgCN is there, NC is attached. But in this case, in our reaction, KCN was there, so CH3CN is formed. Now I am cutting this byproduct. Now in this, if I give H2O H plus partial means not too much water we are giving, little bit of water we are giving. If you are giving partial means only little bit of water, that time what happens? CH3 CO NH2. Simple. CH3 CO NH2. Simple. Now if you give in this CH3 CO NH2, if you give P2O5 heat, then again this will come, again this will form. Means reverse of this reaction H2H plus partial is P2O5. Reverse of this reaction is P2O5. Means if you give H2OH plus partial on this CH3CN, then CH3CONH2 is formed. But when P2O5 is given on this CH3CONH2, CH3CN is formed. Simple. Now one question may come in your mind, that if in the place of partial, if we have given complete, means H2O H plus complete means too much water we have given, then simple this CN will convert to COOH. If too much water, COOH. If only little bit of water, then CONH2. Remember this. Now if we give in this CH3C double bond ONOH in this acid, if you give CNaOH it is a type of electrolysis type. In this what happens, just this CO group is removed, COH group is removed, and one H is attached. Means when NaOH is given, this COOH group is removed and one H is attached, means H4 will come. But I will also show you the types of this reaction. Means for example, is benzene is there, and here benzoic acid, if COH is there. In this, if you are giving NaOH, CaO, just remove this group and attach H, it will come benzene. Okay. If CH3, CH2, then COH is there. If you are giving NaOH, CaO, simply CH3, CH2, in the place of COH, one H will come and it will be CH3. So simply if NaOH, COH is there, then remove the acid group, that's carboxylic group, and attach one H. Remember this? Okay. Now again I'm revising the reaction. If this CH4 is given, Cl2H nu, then again we know CH3Cl will form. In this CH3Cl, if you give benzene and AlCl3, then what happens? Benzene will be there, and this Cl will go to this AlCl3 and it will form a part, that is AlCl4 minus, like this one, something part will form. And what will happen, that is this CH3 will get attached to this benzene. CH3 will get attached to this benzene. And we all know that when CH3 is attached to benzene, that time it is called benzene. Means when CH3 attached to benzene, this is nothing but this product, that is toluene. It is called toluene. Now in this toluene, if you give KMnO4H plus, what will happen? Hot KMnO4H plus. Simply it will form to benzoic acid. It will form to what? It will form to benzoic acid. Now benzoic acid, now you will say, if there is CH3, so this reaction is happening. If there is any other product, for example, if this benzene is there, and in place of this CH2, CH3, beside CH3, anything is there, if you are giving in this KMnO4, hot KMnO4 H plus, if you are giving, this whole thing will go, and it will be COOH. Anything is present here, just remove this and attach COH if KMnO4 H plus hot is there. Remember this. Now let's go to the next reaction. In this reaction, in this benzoic acid, if you give NH3, it forms CONH2. Just this OH is removed, and in place of OH, NH2 is added, and one H flow from this NH3 is attached to this OH, and water as a side product is formed. Okay, so you all know, if in benzoic acid NH3 heat is given, then that OH will be removed and it will be CONH2 in the head of benzene. Simple. Now if you give, now let me write this as a bit open structure. It will be CH3, this C here, NH2 is attached, and in the head of this C, one OH there. Simple. In this, if you give LiLH4, it is also a reducing agent as ZnHgHCl, that we have taken, ZnHgHCl, that one that we have used earlier, that we are giving ZnHgHCl and this their O was removed and two hydrogen attached, CH4 is formed. Same way, when LiLH4 is given, also this oxygen is removed and in the place of oxygen, two hydrogen are attached. So it will form this product CH2 and here NH2. Simple. Now in this CH2NH2, if you give NaNO2HCl, it will form CH2OH. Okay, but if instead of this CH2NH2, just NH2 was present, means in the head of benzene, that is NH2 was present, that means it is aniline was present. That time if you give NaNO2HCl, it would have formed this diazonium salt. This is called diazonium salt. But as here CH2 was present in middle, that's why OH is formed. Now I will explain why this NaNO2HCl, this term. For example, one aliphatic chain was there. Okay, in the aliphatic chain NH2 was present and you are giving NaNO2HCl. Simply this NaNO2 NH2 is replaced by OH in this case. But in case of benzene, when in benzene NH2 is there, NH2, that time if you give NaNO2HCl, it forms N2 plus Cl minus. This is diazonium salt. Means when NH2 was present in aliphatic chain, that time only the NH2 is removed, and aliphatic means when there is no ring, that is called aliphatic, and when there is ring, that is aromatic. When this is in aliphatic chain, when this NH3 was present, that time NaNO2HCl just removes the NH2 and attaches OH. But in case of aromatic, when NaNO2 is HCl is given, that time it is not removing the NH2, it is just converting it to diazonium salt, that is NH2Cl minus. Remember, in this case, if you see, it was this but the NH2 is attached to this aliphatic carbon. This carbon was attached to a aromatic benzene, but the nitrogen was attached to aliphatic carbon, means a chain carbon. That time that's why it is converting it to OH. I hope you can understand this. Next, we all know that anything in the head of anything in the head of benzene, in this here in the head of benzene, OH was present. Anything in the head of benzene, if you give KMnO4 H plus, hot KMnO4 H plus, it will get converted to COOH. Simple. And again we know, in this if we give NH3 heat, just revising the reactions, NH3 heat, it will get formed to CONH2. So I hope till this you have understood. Now I am going to give you another reaction. If you give in this, if you see, this was CH3 CO NH2. In this, if you give Br2 NaOH, Br2 NaOH, Br2 KOH, anything, or if you're not giving this, if you're giving NaBr, like this product you are giving, it will get converted to most common reagent for this reaction is Br2NaOH. If you give this CO group will totally get removed, and NH2 will attach. This reaction of removing CO group, that is Br2NaOH, it is called haloform reaction. Haloform reaction. Okay. Now in this haloform reaction, if you give NaNa2 HCl 0 to 5 degrees Celsius, remember this, it will get converted to N2 plus Cl minus, studied earlier, I've taught. And in this if you give water, it will be formed OH, phenol. In this if you give ethanol, it will form benzene. In this diazonium, that is CH3 NH N2 plus Cl minus, if you give CuCN, it will form this product. If you give CuCl, if you give, it will form CuCl HCl, HCN you have to give. If you give Cl, it will form Cl. Means just the product here that is attached with copper, that will get attached to this in the place of N2 Cl minus. If you give water, after it will come, the only OH will get attached. If you give ethanol, that is CH3CH2 OH, it will form just benzene. So there are many reactions in this video. Till this I have taught many reactions. In the next video I am going to teach you more reactions. So I hope you have learned many reactions in this video. Go through this video twice or thrice. First memorize these reactions. Next video I am going to teach you another set of reactions. So this is a style of teaching out by line maps. In the line maps you get to understand many reactions, you understand many reactions. And if you study that reactions, you go through this, you will memorize this. And when you are doing transformation, or in only for example, if question is coming from just this reaction, just this ozonolysis reaction, if question came, you have learned through this line maps that reaction, so you can able to answer the questions. Thank you. We'll meet in the next video. Goodbye.